Now we look at factoring trinomials with a coefficient that's not equal to 1. And what we mean there is we have a coefficient out in front, 2x squared, 4x squared, 3p squared. It's not 1. So this will be rules that we follow for that. And it would actually even work if it's 1, but that's another video. So these are the form ax squared plus bx plus c. First thing we're going to have to do is find two numbers with a product of a times c. And what I mean by that is 2 times 15 gives us 30. So they multiply to give a product of 30. And we want a sum of b. Now b here is 13, so they have to add to be 13. So we first start off with the factoring. We have to find a scenario with these two numbers. Now if I write out my factors of 30, and I look at all those ways I can multiply to 30, one of them adds up to 13, and that's what I need to find. That is the one set that works. So once I do that, I'm going to split the middle term into those two numbers, giving us 4 terms total, and then we're going to factor by grouping, which is what the previous video was about. So we're going to go 2x squared plus, we're going to go 3x plus 10x plus 15. So split that 13x into two terms. Now factor by grouping. I factor the first two, I take an x out, that's what's in common, leaves me with 2x plus 3. I factor in the next two, 10x and 15, I'm going to factor a 5 out, it leaves me with 2x plus 3. Now the important part we saw with factor by grouping is these two binomials had to match, and they do, so I factor that out, 2x plus 3, and this leaves me with x plus 5, which is my other factor. So that is how we're going to factor trinomial. We're going to go through and practice it. For our next one, we have 2x squared plus 10x plus 8. So let's do the same process. I multiply 2 times 8, and that gives me 16. And I need to add to 10. Now 16 is 4 times 4, but the problem with that is that does not add up to 10. So what are we going to do here? Let's do 8 and 2. So let's go 2x squared plus 8x plus 2x plus 8. If I factor from the first two, 2x comes out, I'm left with x plus 4. Factor out a 2 from here, and I'm left with x plus 4. Now, x plus 4 matches. That factors out, and I'm left with 2x plus 2. Now, we have to be careful there because that is not factored completely. 2x plus 2 has a greatest common factor. I can take a 2 out of this, so I'm going to put 2 out in front, x plus 4, and then when I factor a 2 out, it becomes x plus 1. So my three factors are 2, x plus 4, and x plus 1. Now why that one happened here and not up here is up here we didn't have a GCF, 2, 13, and 15. But up at the second problem, 2, 10, and 8, I could have divided 2 out from the beginning. I didn't do it here because I wanted to show that I could factor. As you get better at factoring, you want to factor out a GCF from the beginning, but I want to at least see the process that we went through. So now we come to our next one. Here I notice they're all even. So I'm going to factor out a 2, and I have 2x squared plus 31x minus 16. Why that's also nice is I don't have to do 4 times 32. I'm only doing 2 times negative 16. So I'm looking to multiply to negative 32, and I want to add to 31. So now we got some negatives. So let's think of multiples or product, the factors of 32. So these are the 3 ways I can get 32, but I need it to be 31. But it's also negative 32, which means one of these in each set has to be negative. And since it's a positive 31, or it's a positive result, it probably means the bigger one is positive. These two, if I make it negative 1 and positive 32, are 31 as a sum. So that's the set we want. We have to be careful whenever we pick them, because if we don't pick the correct value, it's not going to factor. And so we can always go back to that if we do get stuck. So 2x squared minus x plus 32x minus 16. I factor an x out of the first two. Leaves me with 2x minus 1. I'm going to factor a 16 out of the next two, 2x minus 1. So my factors are 2x minus 1 and x plus 16. Bring down the 2, and my 3 factors 2 times 2x minus 1 and x plus 16. On our next one, 3 times negative 40 multiplies to negative 120, and I need that to add to negative 7. So my factors of 120, there's a lot of them. I'm looking for, if it's negative 120, one of them has to be negative, but it has to add to be a negative 7. So I'm going to think, which one of these are 7 apart? These two are 7 apart. This is a difference. And a negative 7 means I want the 15 to be bigger. So I'm going to go negative 15. So we'll go 3p squared plus 8p minus 15p minus 40. The first two terms I can factor out a p, leaves me with 3p plus 8. The next two I'm going to factor out a negative 8, leaves me with 3p plus 8. They both have 3p plus 8. That factors out. P minus 8 is the leftover term. Now we come down to this one, 4x squared minus 36x plus 81. Multiply here, and that comes out to be 324. And I'm looking to add to negative 36. Well, I know already that 324 is 18 squared, and if I did negative 18 and negative 18, it adds to negative 36. I could list out all the factors, but really that's where we eventually need to get. So we're going to go 4x squared minus 18x minus 18x plus 81. I can take out a 2x from the first two terms, it leaves me with 2x minus 9. And I can take out a negative 9 from the next two, leaves me with 2x minus 9. 2x minus 9 is the common term. What I'm left with is 2x minus 9, and look, they actually are the same. It's 2x minus 9 squared. This actually could be a shortcut we could find another way. So let's look over here and rewrite it again and think about this. So there are special cases that show up when we factor. If I looked at this and noticed that these are both perfect squares, and I took the square root, I would guess I could probably put 2x for both of those. And then 81 is also a perfect square, so knowing by multiplication that probably going to have a 9 and 9 there. It's a bad 9. How would I finish this off? Well, I'm not going to put two positives here because it's a negative 36. I can't put one negative because that'd be difference of squares, so it's probably going to be two negatives. So just kind of guessing on that pattern. Now I'm doing a lot of guessing here, but you can always go back and multiply the two together and you get the same result. Now this is not the option to go to that you're going to rely on when you walk in on test time, but it is a way, if you look for these patterns sometimes, to say, hey, look, it does factor down to this, so this pattern of looking for squares does exist. Now, let's say you don't recognize this and this makes no sense whatsoever. You still can go back to factoring, follow the method that we have, and you'll still get a result. All right, moving on. We got 3 times 32 is 96. And I want to add to 20. Now for 96, I could do 12 times 8. That would add to 20 and multiply to 96. So let's go 3g squared plus 12g plus 8g plus 32. I can take out a 3g and it leaves me with g plus 4. I can then take out an 8g and it leaves me with g plus 4. G plus 4 is the common factor. 3g plus 8 is the remaining term. 3w squared minus 24w minus 27. All of those are divisible by 3. So let's take that out. We got w squared minus 8w minus 9. Well, this is a 1, so 1 times negative 9 is negative 9, and I add to negative 8. Well, the way I'm going to get negative 9 is going to do negative 9 times 1. That's going to add to be a negative 8, multiplied to be a negative 9. So we're going to go w squared minus 9w plus w minus 9. We factor out a w from the first two terms. going to factor out a 1 from the last two terms because they already have, it's a GCF already. No GCF between them. So w minus 9 comes out. W plus 1 is left. Bring down the 3. There's our factors. 3d squared plus 20d plus 12. We're looking at multiplies to 36, adds to 20. Well, I'm going to go with 18 and 2 here. 3d squared plus 18d plus 2d plus 12. In the first two terms, I can factor out a 3d, and I have d plus 6. The next two, I could factor out a 2, and I'm left with d plus 6. They match. We take out d plus 6, and I'm left with 3d plus 2. The next one, we have some more variables, but let's follow the same process. But you know what, even before that, they're all divisible by 3. Let's take 3 out. So we got 2a squared plus 7ab squared minus 4b to the 4th. So we're looking to multiply to negative 8. That adds to 7. Well, if I'm multiplying to negative 8 and it needed 7, it's probably 8 and 1. I'll probably keep a positive 8 and a negative 1. So we're going to go 2a squared. Now, when we split this, the variables stay the same. 8ab squared minus ab squared minus 4b to the 4th. Now we can take out, in this first two, 2a, and it leaves us with a plus 4b squared. Now we want the other one to match this, and that's kind of the theme we're seeing here. So let's see what we get here. I got negatives, so I'm going to take out negative 1, b squared, and that leaves us here with a minus 4b squared. Actually, I took out a negative, so it's plus there. They match. That's the key part. As complicated as we make these variables, they just need to come down to matching. So we got 2a minus b squared, and then a plus 4b squared was the common term factored out. Bring down that 3 from the beginning, and there is our factored form. Moving down, we got 5 times 14 is 70, and that adds to negative 17. So 10 and 7 are what multiply to 70, but since it adds to a negative, I got to make them both negative. So we got 5z squared minus 10z minus 7z plus 14. I'm going to factor out a 5z, leaves me with z minus 2. Factor out a negative 7, z minus 2. Z minus 2 is the common factor. That comes out, and I'm left with 5z minus 7. Last one here, I'm going to do 9 times 14. That's 126, and it has to add to negative 65. Well, 126 is 2 times 63. If that's positive, and I want a negative sum, I'm going to make them both negative, negative 2 and negative 63. So we got 4p to the 4th minus 63p squared, keep the variable, p squared, minus 2p squared plus 14. In the first two terms, I can factor out 9p squared, leaves me with p squared minus 7. The next two, I'm going to take out a negative 1. Actually, let's take out negative 2. That leaves me with p squared minus 7. P squared minus 7 matches. We're left with 9p squared minus 2.